Hi guys, and welcome to today's episode on emergence. So this is a topic that I've been very interested in, and I think emergence or emergentism connects very much to my interest in Gestalt and the concept of a whole that is not reducible to its parts. As many of you know, I'm interested in some of the history of that and how it has intersected with Merleau-Ponty and phenomenology, and also I recently wrote a book, which you can find videos about that on my channel recently, but Victor Caston wrote an article in the last year about Alexander of Aphrodisias and his emergentism, his emergent hylomorphism. So this is a topic that I've been interested in, and one of the thinkers, the philosophers who got my interest going really in the term emergence, who I realize I did not type his last name correctly on this slide, is Sean Carroll. And I know he's working on a whole book right now. The third in a series he's been writing is going to be about emergence and complexity. But he's also co-authored a recent article, which we're going to be mostly talking about today. This video, the timing really worked out because I have been wanting to kind of compare and contrast some definitions of emergence according to Sean Carroll, but also how does that compare to my own kind of thoughts on emergence and also definitions of reductionism in contrast. And just recently, Carroll, just this week, like I think on Monday, he released a YouTube video where he talks about this article that he recently published. He co-authored it with Parola. So this is a little bit of a summary for listeners who might want an overview of what they propose in their paper. So I'll get into that paper in my next slide. Okay, so their paper is called What Emergence Can Possibly Mean. And the copy that I found is open access, at least a certain version of it seems to be open access, so anybody should be able to access it. Release was September 15th of this year, 2024. The opening line of the article is, everyone agrees that emergence is important, but they don't agree on what the word should mean. So they're proposing kind of like 4 categories and like subcategories about different kinds of emergence. Some of them Carroll seems to believe in as valid, some maybe not even. He wouldn't even necessarily agree with, but these are different ways of talking about emergence. Anyway, I'll continue here with this quote. They say, the basic idea is that when a system can be thought of as a composite of many parts, there can be novel properties or behaviors of the composite system that are not readily predictable from considerations of the properties or behaviors of the parts themselves. So this is, I think, a good working kind of general idea of emergence. And it's also very much similar to the idea of a gestalt, a whole, which is not identical in the properties of its parts as a simple like lump sum aggregate. There is something different, or as I like to say, kind of relatively autonomous, that distinguishes that higher level system of the whole from the parts, which they themselves might be systems. The parts are, but something about the relation of those parts as a system, that whole can be distinguished from the parts. Okay. So I'm going to be quoting from their paper. Emergence is relevant when there is both a micro description and a macro description of the same system, both of which capture important properties. So their definitions are going to be really important here. I have not super widely read others' definitions in talking about emergence. Carroll and Parola's paper mentions Dennett's real patterns, and that sounds also similar to my own working definition of kind of like a gestalt. It can sometimes be defined as a pattern, and it has some kind of, even if it's just descriptive, some kind of, it packs a punch in some way as, okay, there's a reality to this thing. There's something that kind of delimits it, defines it, and talking about it as a whole or as an entity is reasonable to do, even if it's ultimately a pattern that arises from parts, from a lower complexity theory. So in this paper, they seem to be talking about a micro level and a macro level. And these levels, they talk about them as theories. And they describe the same system. So I think Carroll, I'll talk about this, I think, throughout this video, but he is most, I think, focused in kind of defending, and I completely agree with him on this. I think like 99% I share his, how much he cares about kind of validating that like emergence does not equal woo-woo. It does not need to be talked about as something magical, and it can ultimately be predicted by the fundamental laws of physics. He is, in his general work in his career, focused on kind of fundamental physics, particles and all that. But yeah, they in this paper though say, you know, the micro level does not have to be the super fundamental level of theory of physics. But I think Carroll's focus in his discussion of this, like in his video, I hear a lot of him trying to say, like, here's how we can validate that things can emerge, but it doesn't make them magically autonomous. It doesn't make them magically different from their parts. And I completely agree with him. But what I might disagree with in focus is, in looking at this article that they propose, is like, okay, I might want to talk about it in slightly different terms than you do. And I think part of that difference in the lens that we're looking at it is, I think Carroll just cares so much about making sure that we can honor the fundamental nature of physics, of those lower complexity level theories, and the role that they play. Okay, so I might talk a bit more about that. Okay, so the second quote says, "We take a physics-inspired approach by focusing not on properties or causal dependence, but rather on states and their dynamics. We take a theory or model to consist of a specified space of states and some evolution rule, and investigate how lower-level theories can relate to higher-level ones in these terms." So something that's important to notice is their discussion of emergence is going to really focus on a given, very specifically defined higher-level theory and a lower-level theory. Those are what they mean by macro and micro. And they say the theory plus a corresponding evolution rule, which I won't really go into. You can watch his video, which I will link below, and I'll also link the article. So there are things that I won't go into in full detail in this video, and I'm not even going to go into all the different types of emergence that they talk about in their article. I think these two types are the most important. They have a type 0, type 1, type 2, and a type 3, and I think it's type 2 that they have like an A and B I can't remember which one had like an A and a B. But anyway, these, setting aside type 0 and type 3, I'm going to be focusing on these two. So type 1 is local emergence, and it's defined as a many-to-one map from a micro theory to a macro theory that commutes with time evolution, where both theories describe collections of subsystems and macro subsystems are made of specific micro subsystems. And then what defines type 2, it's similar to type 1, but it's non-local emergence. So micro entities or dynamics that are defined, they are defined non-locally from the micro perspective. Okay, so getting a little bit more into type 1 local emergence. I left that definition of it up there at the top. The second bullet point, subsystems in the macro theory consist of localized collections of subsystems in the micro theory. So a lot of examples of emergence in lower complexity examples fall into type 1 local emergence. I'll talk about this, but type 2 non-local emergence, he says that type 2 corresponds more to like biology, social sciences. When we talk about humans and a human system, it's higher level complexity, and that would be more like type 2. So type 1 is simpler bodies. So the example below says, quote, "We can make accurate predictions for the trajectories of celestial bodies, even after coarse graining their microstates just to the center of mass data and momenta of the Earth and solar system bodies." So we can ignore the vast majority of information about all of those parts and the lower level theories needed to characterize the exact microstate. We don't need all that information. And the higher level theory, the trajectory of the celestial bodies, it emerges demonstrably from the micro level data, center of mass data. But he says you also need to know the momenta of these bodies to calculate the trajectories. So something that Sean Carroll says in the video, where he kind of is explaining this paper, he says something like emergence is not like super connected to time. And I think, to be fair to him, like he would need to like expand more on that, and you would need to hear exactly what he means. But my impression is he downplays a little bit of just how much, when one is defining emergence and the relationship among a macro and a micro, or a whole and parts, we really have to be clear of how is time involved. And I'll talk a little bit more about that later in this slideshow. But he says something that seems to me kind of dismissive of like, yeah, we don't really even need to know like time. It's kind of a present moment emergence relationship. But I just think it's significant that even if you're, saying that you're freezing a solar system in a moment, but you're still needing the momenta, you're still needing to know certain data to make this prediction that is kind of related to time. So time is important, and I think that's something that one of the questions that I ask about emergence is, how does one's definition of emergence relate to space, and how does it relate to time? How are you defining macro and micro when it comes to space and time? These are, I think, important in just how we talk about it, how one defines their terms when talking about this topic. Okay, so type 2, non-local emergence. So again, I put the definition there at the top of type 2 emergence. So the macro theory could involve degrees of freedom that are defined in principle in terms of the microstate, but they are not made of local collections of microentities. They are defined globally in terms of many dispersed parts. Then the macroentities can't be thought of as simply bundles of nearby subsystems acting in a coherent fashion. So something about this language, if I'm hearing it correctly, is similar to saying it's less like a mere aggregate of lumped parts, but more of a system where there can be more of a distant, widely spanning system of parts. It's more complex. It's very clear in their paper that as you go up in the types of emergence, the higher numbers are higher complexity. So this type of emergence, they say, this is a quote, this type of emergence generally happens, I paraphrase this quote, but it comes from their paper. It happens when the macro theory is farther removed from the particles and fields of fundamental physics. And so we'll talk a little bit more about what this means. Okay, they say non-local emergence can become relevant in contexts like biology or social sciences, in psychology or cognitive science, for example. Our higher level theory of human beings might contain things like mental states, which cannot be associated with localized groups of neurons or cells, much less with atoms or particles. They can be associated with appropriate states of all the neurons or all the particles, not with localized groups of them. So that's a really important distinction. Okay, so I'll go a little bit more into an explanation of this, I think also in the next slide, but I'll continue reading here. By our definition of type 2 emergence, there can be non-local variables in the macro theory, but they are ultimately determined by the state of the micro theory. All right, so this is really important. So an example that we're going to talk about in the next slide is, it touches on this, so I'll talk about it just to introduce it. There's the example of you're jerking back in a car when the car is accelerating. So at the human level, say you're talking about a human being as a level of complexity, a level of a theory. That human experiencing that jerk motion, that does not, strictly speaking, mean a top-down causation of the environment being a top-down causation from a higher complexity level. They say that's because ultimately things like a car or environment and all these things on a more macro level are ultimately composed of micro particles. It's just that those particles are not just contained within the human being, they're like all around. So I think that's a really key distinction, and it's one that I completely agree with the way that they talk about that. But when I define the words micro and macro, I think that's where it's like, okay, you can define an environment as micro theory because it's composed of these tiny little things. But I think it's also valid if you want to talk about the environment or a car around a human person as a more macro system, and then the human being is more micro compared to their environment. And then you can talk about that as a kind of top-down, downward causation. I think that's valid too. It's just about defining your terms. What do you mean by micro and macro? Anyway, next bullet point, type 2 does nevertheless open the possibility that non-local effects feed back into the microdynamics in ways that might not have been obvious from a purely micro perspective. So this is another really important point that I like, that the way that they talk about this, I don't ultimately really have any problems with these two types of emergence and how they define them. I think there are other valid ways of defining micro and macro, like I said, but I think there's a lot of value in this paper. So basically, in that example of jerking back in a car, you wouldn't necessarily be able to predict that this human being is going to do that motion from a purely micro perspective of just like the particles that make them up in their own body. So it would not have been obvious, but they say that just means the micro theory, say the theory of fundamental physics or whatever you want to call the micro theory, it just was incomplete, but it doesn't invalidate the fundamental nature of a micro theory as it relates to the behavior of the human person. The micro theory is still, in principle, that's kind of a term that Carroll uses. In principle, it is correct. It's not invalidated by, we don't need another kind of theory. We just need to more widely apply this micro theory so that it applies to all kinds of things in the environment. And even at the most extreme, it's like, okay, maybe we'll need to take into account all of the atoms in all of the universe or something like that, or all of the particles in all of the universe. But talking about it in such a universal way, it can still be seen as the micro theory because it is that level of complexity that is the lowest that we know. So I think that's pretty extreme, and it's not necessarily how people, at least how the Gestaltists, and such, how they've talked about whole and parts. But I think it's valid. But I think it does get to an extreme when you're saying, okay, well, my micro theory is the whole universe, just seen through a certain lens of what level theory of the universe I'm talking about. That's what makes it micro. I think that's one way to do it, but I don't think that's the only way to talk about macro and micro, like I said. And if there's things about what I'm saying here that are going a little bit over your head, just like listen to the episode by Sean Carroll. And I think that you'll get it a bit better. I'm not going into a full explanation of how some of this works. Okay, so I'll just kind of read through here. This is a lot of what I was just talking about. Maybe this will clarify it a bit. So that example, a jerk motion from an accelerating car or like an elevator. They say the jerk experienced by a macroscopic person supervenes on some not entirely local set of microdata. So this data is the state of a car, the driver, the road conditions, as well as the local state of the passenger. Okay, so we kind of talked about that. It's the idea of like the macro is the person, and then the micro data also includes the car, the driver, the road conditions, all of this, which to me, that's how I usually talk about a more macro system, is a wider environment, but that's not how they are talking about macro and micro in the way that they see that example. They say there is an appearance of downward causation there, but it's really counterfeit downward causation because in their definition of micro, the micro theory can contain all the micro level stuff in the universe if it needs to. Or in this case, the micro level stuff is the state of the car, the driver, the road conditions, all of that. As long as it's seen through the lens of like these are things that are composed of these fundamental particles. Okay, so defining terms here is crucial. Like I said, some use macro to mean the width of one's environment, and I'm going to talk about this in one of the next slides. So like, is the space of the macro larger than the space of the micro system? Or like they're talking about it, macro and micro correspond to the theory level, the complexity of the theory, which is not necessarily locally defined. It can be universal in its span. Okay, so this is kind of where I talk a little bit more about these different ways of defining macro and micro. I think that there's a lot of value in the way that Carroll and Parola talk about macro and micro according to the complexity of a theory, which is what I describe in point number 1 here. They're not as concerned about a micro theory, a part being contained in a certain smaller space or time than the macro. The micro is perhaps incomplete in predicting the macro phenomena or theory, but in principle it's sufficient when it's seen as a universal, so when it's not just limited locally, which is what I've been talking about. Okay, so number 2, which is a little bit the way that I more often tend to think about macro and micro, or whole and part, is in regard to space. Macro as in a larger amount of space, micro as a lesser amount of space within the larger whole system. What I usually think about is systems not on a universal theory level, but within a given spatial system. So one particular human being, one country, one organism, talk about one baseball game. So these are not like, when I talk about a human being, it's not just some kind of theory that defines the essence of a human being in general. I talk about one particular human being and the system of parts of that human. So less universal kind of terms here. Okay, and so you can also compare the nature of one human versus another. I would like to hear more from Carroll about how he talks about, like, how do you define a theory? Because their definition, as you can see, like, of emergence relies very much on like a higher level complexity theory and a lower theory. And he talks in his video about like a human being, a human person as that macro theory. And I'm like, are you saying you can contain a human person into a theory, or are you talking, are you talking more just on, in general terms, the principle that you can kind of define a human being in their nature generally with some kind of theory? But I think, I tend to think about emergence of a particular thing contained in space, and also time, which brings us to number 3. You can think about a whole compared to its parts also in relationship with time. So sorry that the words here are blocked out. Micro as in smaller or even no amount of time, like a frozen kind of scene with no time passage. So an example comparing like evolution, which I think time and evolution are key to their definition of emergence. They say like, yeah, you need to know the macro theory, the micro theory, and also the evolution laws of those things. So you need to know kind of a lot in order to define these this emergence according to their article. But you can say the macro is evolution over time, selecting for certain outcomes, which determine the behavior of biological components, which are living in a shorter given span of time within that larger timeline of evolution. So the larger whole of time determines the kind of forms of life that are emerging in a certain lifespan, maybe within 100 years compared to like thousands, millions of years. So there's the macro, in a way, determines the micro, because there has been all this time that like led up to this life form emerging. It did not simply emerge from this random activity of particles. When you look in just the present moment, there is randomness in atoms and these fundamental particles in physics. But over a span of time, we see that there is something determining the emergent, say, human being, this life form that is me, is determined not just by my parts in that sense, but by the whole of species or all of animal species interacting with environment, with everything in this planet, on the surface of the planet, kind of, and elements and weather, all of that. To me, that is something that I don't have a problem with talking about downward causation, or the whole environment, the whole of a time span determining something smaller within that time span, determining something that is smaller or living for a briefer amount of time. But in principle, I agree with them that there is still this fundamental law of physics. You want to call it fundamental as far as we know at this point. It's the most fundamental theory that we have right now, is what we know about fundamental physics. But it is just like, okay, apply that to the whole universe. And yeah, that does add up to a down-up causation of like my life form emerging. It's just about how you define your terms and how universal you're applying your micro term. So just in this slide and the last slide, I want to talk a little bit about just kind of like the idea of whole determining its parts, or downward causation in Gestalt theory, Kurt Goldstein, and the book I'm familiar with from Merleau-Ponty is Structure of Behavior, where he talks in similar terms about wholeness in Gestalt terms. And this is the way that I like to kind of just briefly talk about it. I'm not a physicist. I don't know how to really define systems in formulas, but I think it's great that physicists do, and that Sean Carroll can propose in his article these formulas to describe these different categories of emergence. But basically the gist is, I think that there are other briefer ways to talk about causality and systems and the macro and micro that might be slightly different from the way that they're talking about it, but it's all consistent. It can be consistent with physics. It doesn't have to be woo-woo. I respect the people who want to be woo-woo, but that's not my view. I'm very much physicalist, materialist kind of person. Basically, I think I don't see certain things as like magical, or I'm not a panpsychist, these things. So I very much share the perspective of Sean Carroll, but I think that I'm just not really threatened by the term downward causation, as long as we're defining it in a certain way that I agree with. So anyway, I'll just kind of read through this list of kind of concepts or phrases that I'm familiar with from the Gestalt perspective. So Gestalt is a whole which is not reducible to the sum aggregate of its parts. I think a lot of us can agree on that. I don't think that's particularly controversial. I think that's pretty obvious, actually. They also talk about this principle of a whole determines its parts. That I think is like much more controversial. It's a kind of framework, a kind of almost like attitude of seeing the world. And it's less obvious, I think. It's an attitude that was very important to Kurt Goldstein. But I think the definition of terms here is important. So I think with Gestalt and Goldstein's organismic perspective of Gestalt ideas, whole is determined as like an organism, and its parts is basically just things like its behavior or its organs, like its members of the whole, which are in a way on that same macro level of the human person. It's not that my body determines the behavior of the atoms or the fundamental physics particles. So it's really important to define what you mean by whole determines its parts. But I think that there is something descriptively useful in talking about a whole determining its parts, that it's about what system are you focusing on? Like, how are you defining a system? If I'm talking about a human person, or a human person interacting with my environment, interacting with other human beings who are causally affecting something in me. So if someone is threatening me, It's going to determine my bodily systems, how it's acting, how I'm behaving. These are not things that just arise from my ingredients without external stimuli. So there are a lot of times I think that it's valuable to talk about a whole determining parts, or a system as a whole determining its components. Obviously, I think a lot of people would agree with that. It's just about how you're defining a whole determines its parts. So like I said, the whole, according to these thinkers, can often be seen as the organism or the organism environment system. Okay, and so, and then I'll talk on this next slide, but also the kind of emergentism that Victor Caston talks about in Alexander of Aphrodisias is similar. Downward causation is kind of defined as the whole determines the behavior of the parts. So the human, with what Alexander calls a dynamic form, determines the behavior of the parts, even if that human being kind of emerges from their material makeup, the substrate that are kind of the ingredients of them. So it just kind of depends on how cool you are with defining parts that way as behavior of a thing. I think that that's an area of difference, that Sean Carroll isn't talking that way about parts. Okay. And again, just according to kind of the perspective that I usually take, I come from this kind of Gestalt perspective. They want to really focus on a concrete situation. It's not so much a universal level of a theory. It's how is a system defined in a lived experience, a concrete situation, like a baseball game. There is a historical givenness. Merleau-Ponty talks about this in his book, The Structure of Behavior, about like any kind of law or theory, he says, is kind of determined by its givenness in space and time. We have to acknowledge that. And I think that's a really important point that Carroll, I think, kind of skips over, is like, do we really know that the Big Bang was the beginning of everything? What could have preceded? What could have come before the Big Bang? We don't know. So do we really know what is at the fundamental level of our universe? We don't know what else could be there. People used to think that the atom was the most fundamental thing, and then we learned about what underlied that. So there's always this question of like, what substrate or what field in physics will we learn about next? So we don't really know if everything just kind of fundamentally arises from something that is most simple, most the least complex phenomena, levels of complexity that we're talking about. It would seem, if we're starting with the Big Bang, that the universe started with a low level of complexity, and then complexity evolved over time. But that kind of depends on what's our starting point. And Carroll says that himself, is okay, if we start with the Big Bang, and then add our evolution laws, and we work upwards from there. But that depends on your historical starting point. Okay. And Kurt Goldstein also is someone who wants to talk about wholes as a unique person, the personality, the personal situation. All the Gestaltists really want to talk about that. So again, like, you have the field of physics versus the field of counseling, or like psychology. I, as someone in more of the psychology side of things, think there is so much to a value in focusing on a system as a unique human person with a high degree of complexity in a lot of specific factors in that given concrete situation. I'm not thinking in a universal theory kind of way, but a physicist is going to talk about complexity in a universal kind of theory. And comparing theories in a more universal way. So I think that's completely appropriate, and I think that is, again, really important that they're talking about things for the physicists out there and for all of us, because physics is universally very important. But it just comes down to like, are there other ways of defining emergence or whole in parts? Yes. And I think that that's just fine. So not everyone needs to talk about emergence in only these 2 or 3 categories that they propose. I actually don't think that that's the only valuable way to define a whole and parts. I think it really actually gets really messy if you're trying to just define emergence in these very limited ways through the physics lens. It doesn't apply super neatly to psychology. It's consistent. Yeah, I totally agree. But other ways of talking about a whole and parts or downward causation, I think are very valid. And I don't think that that Carroll, I just don't think he focuses on that. That's not his specialty. So I think like take that with a grain of salt. Okay. All right, so the last slide, I kind of talked about this. I think there's a lot of similarity between hylomorphism and the Aristotelian tradition, which is Alexander of Aphrodisias tradition. It's very similar to the Gestalt, the immanent wholeness of a form in the Gestalt framework. Alexander of Aphrodisias, hylomorphism, emergentist hylomorphism. There was an article recently by Victor Caston where he kind of defines emergentism and proposes that Alexander's concept of a dynamic form is emergentist. He says, because the distinctive behavior of bodies is produced from the top down, downward causation, while also being a function of the underlying matter, upward causation, Alexander's framework can be considered emergentist. In a manner of speaking, the whole emerges from certain parts, and the whole determines other parts. So if you're defining parts as like the behavior of the whole human being, yes, the whole human system determines its behavior, or the human environment system determines the behavior of a human being. But also the human and its environment all ultimately are composed of lower level parts, like atoms. So that's kind of what Victor Caston says in his article. Dynamic forms determine the behavior of the body while they also arise from the material components of the body. The form is nothing magically added to make it a whole organism. It's just kind of in that way. Alexander is fairly materialist. He says things like the soul kind of arises from its material parts. So the Gestaltists, Alexander, Aristotle, I think, debatably, these are not like very vitalist woo-woo thinkers. Aristotle, you might debate about like how did he see the soul, how much of a magical kind of entity did he think of it as. But I think with Alexander, you see some pretty clear indication that he talks about the soul as emergent, but also downward causation of a form or of a soul. Okay, so I think that is kind of an overview of the thinkers that I have studied in the last few years, comparing Sean Carroll's definitions of emergence. So I hope this is helpful, a helpful overview. If you have any thoughts, please comment below, and I will link all the relevant sources I've mentioned in this video in the description, so please check them out. I'd love for others to check out the paper by Carroll and Parola and Carroll's video on emergence, and look out for Sean Carroll's book that he's I think still in the process of writing on emergence and complexity. I think it's a super important topic that we should all be grappling with. Okay, how do I want to define these terms of emergence and complexity? I think we should all be talking about it and thinking about these things. I think they're really important. All right, thanks.